Welcome to PM Ready, your guide to becoming PMP certified. This lesson is on planning quality, part 2. And now it's time to take a look at the inputs of the planned quality management process. But this time, we cover the process inputs in reverse, starting with the organizational process assets and enterprise environmental factors. Because the quality management plan needs to be built on the foundation of the organization's existing quality management system, if any, including the policies, procedures, and guidelines for quality management. You should also take advantage of your organization's quality templates, including templates for the quality management plan itself, check sheets, traceability matrices, and any other quality tools. And as always, consult your organization's historical databases and lessons learned repository to find examples of quality management plans and tools used on previous projects, as well as lessons learned about managing and controlling quality. Particularly for quality management, you need to ensure compliance with government regulations, as well as industry and specialty rules, standards, and guidelines. Quality can be more difficult to manage and control when project team members and work are spread across multiple geographic locations. Different locations can also have different governmental and cultural perceptions of quality and how to achieve it, as well as different advantages or disadvantages in local working or operating conditions that can affect quality. In addition, your organizational structure can affect how and to what extent you can control quality and who you may need to engage in order to set up the level of quality management needed for your project. Last but not least, marketplace conditions, including customer perceptions and expectations, as well as competitors and their offerings. These set a de facto standard for quality. In addition, there are several other documents you should review for quality requirements. These include your project charter, which has in it your project objectives, which should be measurable, your product characteristics, approval requirements, and project success criteria. Also look at your stakeholder register and stakeholder engagement plan to find out who you need to talk to and how in order to elicit quality requirements. Your requirements documentation, requirements management plan, and requirements traceability matrix, because your quality requirements need to be linked to specific functional and non-functional requirements. And these can also contain the tracking of your quality testing. Your scope baseline includes the acceptance criteria for your deliverables and the WBS framework that provides the basic structure for organizing activities, schedules, costs, and quality requirements. Your risk register and risk management plan should be consulted for information on threats, opportunities, and risk responses that affect and are meant to ensure quality requirements are met. And finally, your assumption log will contain assumptions and constraints regarding quality requirements. Now on to the tools and techniques of the planned quality management process. Quality management is an entire discipline unto itself, so you shouldn't hesitate to consult with experts in this field. And that's why expert judgment is at the top of the list. Meetings are also there because you'll have plenty of meetings with experts and many others to determine your quality requirements and your approach. Different data gathering techniques that are applicable here include things like benchmarking, in which you can compare practices and performance to other projects, both inside and outside your organization, especially similar projects in your industry or field. Brainstorming, which you can use to creatively gather suggestions and input from team members, stakeholders, and experts on how to apply quality management principles to your project. Interviews can be especially beneficial if you want to learn information that people might otherwise be reluctant to share in a group. Data analysis includes cost-benefit analysis, which you can use to compare alternative approaches and assess which quality controls are the most beneficial and cost-effective for your project. Quality management plan should be based on a strong foundation of detailed analysis of the cost of quality, including the costs of prevention, appraisal, and failure associated with different approaches and tools. You'll also need to use decision-making to decide on the right balance of quality activities to yield the best return on your investment in quality. And finally, you have test and inspection planning, because you should decide ahead of time what you will test or inspect, when, and how. Other tools and techniques for planning quality management include various data representation methods. We have here just a few. There are several more in the quality tools lesson. The ones here include flowcharts, which are sometimes referred as process maps or process flows or process flow diagrams. Flowcharts can include value chains. A value chain is a flowchart that shows the process steps of how you add value to goods and services, from the sourcing of raw materials to the delivery of completed products or outputs. One example of a value chain is the SIPOC diagram from Six Sigma. Flowcharts can help you to understand and estimate the cost of quality for a process. At each step in the value chain, you can analyze the work that is being done, what the quality requirements and risks are at that step, and estimate the cost of quality at each point in the process. Then you have logical data models. These are simple diagrams of the data in an organization, such as customer data stored in a database, and it represents this data in a simple way that allows you to identify data issues. You also have matrix diagrams, which allow you to explore the relationship between various factors, causes, objectives, and quality requirements. And mind mapping, which is a simple diagramming method used to represent a central item of some kind, such as an idea or a problem or a goal, then to brainstorm and connect and organize ideas or factors or influencers or whatever around this central issue. Here's a simple diagram of a SIPOC flowchart. These types of flowcharts are used commonly in Six Sigma projects. SIPOC is an acronym that stands for the major parts of this flowchart: supplier, input, process, output, and customer. This flowchart identifies the different suppliers, what their inputs are to the process, different process steps, what the outputs are, and who the customers are, and along the way identifies the requirements and measurements needed or used during this process. Similar in some ways to a context diagram, the SIPOC flowchart can help you to see the big picture, and from here you can drill down and create a more detailed value chain. Here are a couple of flowcharts or what you would call process maps that you can get from NASA from their published information about how they manage risk. Here on the left you see this colorful one, which shows these different rectangles in which it shows that to manage their risks, they start with the process of identifying risks, analyzing them, planning what to do about them, tracking them, and then controlling them. And you can see there are various arrows in and out representing inputs and outputs, and also repeating loops, such as between control and plan. Other times, like on the right, in this black and white flowchart, you can see from their documentation a more traditional flowchart that uses these traditional symbols where it shows these ellipses at the beginning and end shows start and end of a process. So you can see it starting at the top and working its way down to the bottom. The rectangles represent activities or processes. Then you have the rectangles with the wavy bottom, which indicate documents. And then the cylindrical ones, which represent databases, typically in computer systems. Here's an example of a different sort of flowchart or process map. This one comes from the United States Department of Defense. It looks like it is meant to be printed out on a huge sheet of paper and mounted on a wall somewhere. Zooming in on just a part of this larger process map, you can start to see some of the details of the different steps along the way, the arrows that connect these different processes, some of the diamond-shaped processes, which are actually not processes but questions that you ask, or decision points. And based on these decision points, you go one way or another in the process map or flowchart. Some flowcharts are extremely detailed to the point that you can actually write computer code based on them, and others like this one are meant for you to see at a high level what the different steps are that you should be following in a complex process. Here are a couple of examples of logical data models. Here on the left, you can see that it represents 3 different types of information about customers, orders, and items. And then on the right-hand side, in the blue ovals, you can see that it has the details for each of those objects. So name, address, and email for customer, and so on. Notice that these are represented in a very simple way without a lot of technical detail or anything, so that this can be understood by business people and you can collaborate with them on the different pieces of data that are here and how they all link together. And here's where you can identify linkages that are inappropriate, or data that's missing or redundant, or even data that lacks integrity, meaning that it is missing something, or it's ambiguous, or doesn't match with data in other places in your database. Or it could be simply incomplete in some ways. Matrix diagrams, which you can use to see relationships between quality requirements and other factors on your project, can be as simple as this L-shaped diagram, which shows rows and columns like a typical spreadsheet, or this one on the right, which shows relationships among 3 different categories of factors. And here's an example of a mind map. Here in the center, you can see this main idea or question or issue, and then you simply draw all these little other ideas or things that are related to it and group them by themes or categories. And this way you can organize your thoughts and approach. Mind maps are very closely related to and often used with brainstorming to quickly generate ideas and organize them. And they're useful in many different contexts, including requirements gathering and exploring different ways to approach quality management. How much do you remember about the inputs, tools, and techniques and outputs of the planned quality management process? Remember to start with the key outputs, which in this case include the quality management plan and quality metrics. Other secondary outputs are natural because as you're working on quality, it can affect other plans and documents in your project, including your scope, your risk response planning, and risk management plan. It can inform also your lessons learned, and you may discover new stakeholders and new stakeholder needs as you're exploring quality that need to be recorded in your stakeholder register, new risks and new aspects of risks that need to be recorded in your risk register, and updates to your requirements traceability matrix for quality testing and tracking. In this case, your organizational process assets are a key input, even though they're listed on the bottom, as they always are, because it's so important for the quality management plan to include your organization's quality standards. You also have enterprise environmental factors as a major input, and then a whole host of other documents that can provide information about quality requirements and needs for your project, starting with the project charter, different components of your project management plan, and several different project documents. Tools and techniques include expert judgment. This is a big field, and so please take advantage of experts. Other tools include data gathering tools, data analysis tools, decision making, and various data representation tools. You'll also have loads of meetings, and you'll need to plan your testing and inspections. In addition to the focus on minimizing variation and meeting stakeholder requirements that is fundamental to modern quality management, there are a few other trends to mention. The first is that it's not enough to deliver the agreed scope on time and on budget, as has previously been the focus of project management. We've realized as a profession that we need to do more. We need to focus more on overall customer satisfaction, which is a combination of conformance to requirements and fitness for use. This means that we need to make sure that we understand the stakeholders and their needs well enough to collect a complete set of requirements, and that projects deliver real value that meets stakeholders' needs and is not just checking off all the checkboxes of requirements, but is actually fit for use. The next trend is the recognition of the need for continual improvement. We shouldn't let the temporary nature of projects blind us to the long-term benefits and the need for continual improvement of both projects and operations. Quality principles and tools that originated in manufacturing and other operations can be applied to the continual improvement of projects to improve not only the products, services, or results of projects, but also to improve how effectively and efficiently we manage projects. These include the Plan, Do, Check, Act, or PDCA cycle, doing it right the first time, total quality management, Six Sigma, Lean Six Sigma, the theory of constraints, and more. Although quality leaders have been saying it for decades, there's still a need for management to realize the essential role that they play in not only supporting quality, but in leading the establishment of a culture of quality. Another trend that was championed by Deming and widely applied in Japan is the preference for fewer suppliers and partners and having close relationships with those fewer suppliers and partners. The idea is to understand each other's needs and their processes and constraints and so on, and to proactively help each other to improve. In the United States, we have a long tradition of more arm's length transactions and relationships. However, for those who are willing to change their organizational culture to adopt a more collaborative approach with suppliers and partners, the long-term benefits are well worth the effort. The Agile approach has some wonderful advantages when it comes to quality. Quality isn't just added on, it's built into the foundational Agile principles. Agile principles emphasize the need for frequent, even daily collaboration between business people and the project team. The whole structure, the whole schedule framework is built around showing the key stakeholders something that actually works every few weeks. This creates a better understanding of stakeholders' requirements and needs and allows the team to identify the need for changes and to make course corrections early before it becomes really expensive or infeasible to make these changes later in the project. The project team also meets regularly, usually every few weeks, for a retrospective to discuss what's going well, what's not going so well, what could be done to improve, and what impediments, which, if removed, would improve the productivity of the team. This allows teams to identify and resolve issues early on and to significantly improve the quality and speed of their work. In this lesson, we've reviewed the question, what is quality? Which in short is the fulfilling of requirements. Grade is different from quality and comes in different levels and is independent of your requirements. The focus with quality is prevention over inspection. In other words, we want to build quality in rather than inspect or test it in at the end. We covered two different types of sampling. Attribute sampling, in which you measure whether or not something is present or passes or fails. It's a yes or no question, basically. Versus variable sampling, which are measurements that are based on a continuous scale, such as when you're measuring length or duration or volume and so on. We reviewed tolerances versus control limits. Tolerances are the specifications that you've been given for acceptable quality. Those specifications come from your key stakeholders. Versus control limits, which are inherent in your process and are used to measure whether or not your process is in statistical control. Preferably, your control limits will be within your tolerances. We also went over the cost of quality, which includes not only the costs to build in quality, but also the costs of poor quality. These are organized into different categories, including prevention costs, appraisal costs, rework costs, and warranty costs. You should be familiar with the cost of quality categories and all of these terms and how they relate to each other. The quality management plan is your rulebook for how to manage quality on your project, and your quality metrics specify what you're going to measure and how you're going to measure it. For more information on planning for quality, you can refer to these pages of the PMBOK guide. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.